Let us begin with the cube of a number. A cube of a number is a number when it is multiplied by the square of that number. It is the third power of a number. For example, if we want third power of 4 or 4 cube, it is equal to 4 into 4 square, and 4 square is nothing but 4 into 4. So 4 into 4 into 4 is 64. So 64 is cube of 4. Now we are going to learn various methods of finding out the squares of number, which is near base, near subbase, or otherwise as a general method. In the multiplication of three numbers, what we were doing is we were writing their deviations from the base. Answer was bifurcated in three parts. Right hand part is d1 into d2 into d3. Middle part is sigma d1 d2 or d1 d2 plus d2 d3 plus d3 d1, and left part one number and other two deviations added together. In case of cubes, n1, n2 and n3, they are same. So it is n into n into n. So instead of d1, d2, d3, it will be d, d and d. So that d1, d2, d3 is nothing but d into d into d. d1, d2 means d square plus d square plus d square, and n plus d plus d. So let us deal with the cubes of numbers which are near base. So near base means when the numbers are near 10, 100, 1000 and so on. The prevailing conditions which were there for multiplication, they remain the same. For example, when the number is near 100, rightmost and middle part, they will be of 2 digits each. When it is 1000, it is 3 digit. When it is 10, it is single digit, and rest being carried forward. Now let us consider what is the cube of 104. In case of 104, this number is near 100, deviation is 4. So n plus 2d, n is 104 plus twice the deviation, 2 into 4, 3 into d square, d is 4, so 3 into 4 square and 4 cube. 4 cube is 64, which is 2 digits is set. 4 square into 3, 48, and 104 plus 8. So 104 cube. All these steps can be carried out orally so that we can write the answer directly. It is 106 plus twice of 6 means 12. So 106 plus 12. 3 into 6 square. 6 square is 36 and 36 into 3 is 108. But because our base is 100, we want only 2 digits. The third digit will be later on carried forward. And that d cube means 6 cube, which is 216. Again 2 digits, third digit will be carried over. So 118 plus 1, 8 plus 2. So 1191016 is the cube of 106. If you want to confirm whether our answer is right or wrong, by Bijank method we can check it. Bijank of 106 is 7. Operation is cube. So 7 cube. And its Bijank is 1. So Bijank of the question is 1. Bijank of the answer, 9 cancels, 6, 7, 8, 9. Remaining is 1. So Bijank of question is same as Bijank of answer. Now let us take some examples to find out the cubes of numbers which are near base. So suppose if the base is 10. So what about 11 square? So 11 is n plus 2d. Deviation is 1. So 11 plus 2 is 13. 3 into d square. 3 into 1 square is 3. And 1 cube is 1. So the answer of 11 cube is 1331. If we want 9 cube, in case of 9, the deviation is bar 1 or minus 1. So 9 minus twice the deviation is bar 2. So 9 minus 2 is 7. 3 into bar 1 square is 3. And bar 1 cube is bar 1. So whenever the deviation is negative, always we get a vinculum number, because the right hand part, cube of a negative number is always negative. So the answer is 7, 3 bar 1. 3 bar 1 is 29, 30 minus 1. So 729. Cube, near 10, 3 is the deviation, twice the deviation is 6, 13 plus 6, 19, 3 into 3 square is 27, because 10 is the base, we want only single digit, 3 cube is again 27, so we want only single digit, this 2 is carried over, this 2 is carried over to the next place. 19 plus 2, 7 plus 2, 2197 is the cube of 13. Now when the base is 100, say for example 102 cube, base is 100, 2 is the deviation, twice the deviation is 4, so 102 plus 4 is 106. Middle part 3 into d square. 3 into 2 square is 4 into 3, 12. And 2 cube is 8, which is a single digit. Base is 100. To make 2 digits, it is 08. This is the cube of 102. 100 is base, deviation is 3, twice the deviation is 6, 103 plus 6, 3 into 3 square or 3d square, 27, 2 digits, 3 cube, 27, 2 digits. So 1092727. Here the deviation is 5, twice the deviation is 10, 105 plus 10, 3 into 5 square, 75, 5 cube is 125, which is 3 digits. So this one is carried over. Is the cube of 105. So like this, you can find the square cubes of the numbers which are near base. If the deviation is negative, say if it is 96 cube, so here the deviation is bar 4. So twice the deviation bar 8, so 96 minus 8. 3 into bars 4 square, 48. Bar 4 cube, 4 cube is 64 with negative sign. Normalize this, 800 minus 64 or 1 less than the previous one, last from 10, others from 9. So this is the cube of 96. (92) cube, here minus 8 is the deviation or bar 8. So minus 16. 3 into d square. So 64 into 3. 192. But our base is 100, so only 2 digits. Third digit will be carried out later on. And 8 cube, 512. But because it is negative, it is bar 5, 1, 2. So this goes here, 77, bar 5 means minus 5. So the vinculum number converted so 778688 is the cube of 92. The one thing, when the deviation is negative or when the number is less than the base, always the right hand part will be a vinculum form, which we will have to take care of and normalize it to get the proper answer. So in the similar fashion, when the base is 1000, 10,000 and so on, so what is to be done? It is the same thing. Only thing, we will have to be sure of number of digits in right hand part and middle part of the answer. So it is the 10,000 is the base. That means middle part and right hand part, there are 4 digits each. 8 is the deviation plus 16. 3 into 8 square, 192. But it is 3 digits. We want 4 digits. So it is 0. D cube is 512. 4 digits. So the answer is 1002401920512. $99,993 cube is how much? So in this case, base is 1 lakh, deviation is bar 7. So twice the deviation is 14. So reduce the number by 14. 3 into 7 square, 147, but we want, because of 1 lakh, we want 5 digits. So 2 zeros are given at the back, and minus 7 square, 343, because it is minus, this part will be minus with 5 digits. Normalizing it, we will get the answer as 1. Just you can imagine what is the number of digits in the answer, and easily in a single step we can carry out the procedure. So now let us deal with the cubes of numbers which are near subbase, means the numbers which are near 20, 30, 40, 50 or 200, 300, 400, 500 or 2000, 3000 and so on. The formula remains same, the one which we have used for cubes of numbers near base, with little modification. This is the formula for cubes of numbers near base. For subbase, the ratio comes into picture, which we have seen in case of finding out squares. So ratio is subbase upon base. It is better normally to choose the lower base. So multiplied by r raised to 0 means 1. Multiply the middle part by r means 3d square into r, and multiply the left hand part by r square. Square of the ratio, left part, middle part into ratio, right hand part remains the same. So it is equal to r square n plus 2d r into 3d square dq. So the rest procedure remains same. 100 base or 200 base 2 digits, 1000 base 3 digits, and so on. For example, 21 cube. In case of 21, subbase is 20, base is 10, or 20 is 2 times 10. So that ratio is subbase upon base, and deviation from subbase 20 is 1. So using the required values, you will get directly whatever the result is. R square means 2 square, n is 21 plus twice the deviation, 2 into 1, r into 3 into d square dq. So 21 plus 2, 23 into 4, 92. 2 3s are 6. 10 is the base, so only single digit. 1 cube is 1. So the answer is 9200. 61. 34 cube, subbase 30, base 10, ratio 3 and deviation 4. R square is 9, 34 plus 8, 42. Ratio 3, 3, deviation square, deviation cube. $378. 4 4 is 16, 3 3 is 9, 16 9 is 144. 4 cube is 64. So just whatever result is there, carry on. So it is 4, 10 means 0, 15. So 39304 is the cube. If I want the cube of 304, now the base is 100, subbase is 300. So 300 by 100, the ratio remains the same, deviation remains the same. Only thing is right hand and middle part, they are of 2 digits. So it is 9 into 304 plus 8. R. So 280, 312 into 9, 144, but our base is 104 cube. So this one is carried over here. So the answer is 28094464, which is the cube of 304. What is the cube of 1997? Here this number is near 2000, so subbase is 2000, base is 1000, ratio is 2000 divided by 1000, and bar 3 or minus 3 is the division. So R square is 2 square, 1997 plus 2 into bar 3 is bar 6. So 1991. R 3. And right hand and middle part, as the base is 1000, 3 digits. 4 into 1991, 2 3 the 6, into 54, base is 1000, so 054, 3 cube is 27, bar 3 cube is bar 27, 3 digits. So the answer is this is the answer. So in this way, using subbase, we can find out the cubes of big numbers which are near either base or subbase. You can choose any of the base and find out the cubes of number. For example, let us take only one example, say 52 cube. Now this 52 is in between 10 and 100, so that either we can choose the base 10 or we can choose the base 100. Better to choose always lower base, otherwise the possibility of getting a fraction number and then transferring will be there. So it is better, but just I am showing it how it can be carried with base 10, 50, so ratio is 5, deviation is 2. R square is 5 square, n plus twice the deviation, deviation is twice means 4 plus 52, R 3 d square dq. As the base is 10, these two will be single digits. So 25 into 56, 5 3 is 15, 15 4 is 60, but we want only single digit, so 60, 2 cube is 8. So the answer is 140,608. So instead of 10 as a base, if we choose 100 as a base, 50 will be our subbase because the number is near 50. So that ratio is subbase upon base, or 50 upon 100, which is equal to half. So instead of 5, because of base 100, the ratio is now half. So half square is 1 by 4, ratio, so half into 3 into 2 square, 2 cube. Everything remains same, but as our base is 100, right hand part and the middle part, they are two digits. So 56 divided by 4, 3 to the 6, but we want 2 digits as it is. Base is 100, 2 cube is 8, so 140608. Here subbase is 2 lakh, base is 1 lakh, ratio is 2, deviation is bar 4. So R square is equal to 4, twice the deviation is minus 8, so 1,999,88. R is 2 into 3 into dq, and as our base is 1 lakh, these two, middle and right hand part, will be of 5 digits each. Sixteen 6, but we want 5 digits, and minus 4 cube is bar 64, 5 digits. So the answer is 79995200953. 9, 9, 9, 3, 6. So in this way, the cubes of numbers which are near surface can be carried out very effectively in a step or two. So now let us learn something about the general method. Of finding the cubes of numbers. The cubes of numbers is similar to one which we have discussed in case of squares of numbers by ratio proportion. So Anurupena was the Vedic formula which was used, that is proportionately. Here also, now let us see first for n square what we have done. So when it was a 2-digit number, say 12 square, we found the ratio of tens and unit place digits as 1:2. Then we wrote square of 1 followed by maintaining the ratio and writing 3 consecutive numbers. Later on adding the middle digit or middle number and adding together. 144 was the square of 12. In this similar fashion, when we want a 12 cube, again the ratio is 1:2. Now instead of finding out the squares, now we will be finding out the cube of tens place number or digit. 1 cube is 1. Maintain this ratio, but write 4 consecutive numbers instead of 3 consecutive numbers. Here next step was adding same middle number. Now there are 2 middle numbers. Add double the middle digit or middle number. Double of 4 is 8. Double of 2 is 4. Unit place, tens place, hundreds place, and so on. So 8. 8 plus 4, 12. Carry over 1. So 12 cube is 1728. So if at all we want 21 cube, so 2:1 is the ratio. 2 cube is 8. Half of that, because 1 is half of 2. Half of 8 is 4. Half of 4 is 2. Half of 2 is 1. Add double the numbers. Add together. 1 is carried forward. And 9261 is the cube of 21. If it is 33 cube, so the ratio is 3:3, means 1:1. So 3 cube is 27. 1:1 means 27, 27, 27. So 27:27 means 1:1, 1:1. So we maintain the ratio. Add double the number. Now B is a single digit. You keep only single digit, carrying forward the second. So 33 cube is 35,937. So now as far as these 2-3 examples are concerned, the ratios were very simple. But if the ratios are say 3:7, 4:9 and something like that, then how to cope up with that? So it is nothing but the algebraic cube. How it comes, let us see. Just so A bar B, that is unit place and tens place. If this is a number and we want to find the cube, what we take is the cube of tens place. So cube of A is A cube. Now the ratio is A is to B, so that to maintain the ratio, now if you observe, the ratio A cube upon A square B is nothing but A is to B. A square B upon AB square is also nothing but A is to B, because AB cancels, and in this case B square cancels, and so the ratio is A is to B. So we are maintaining the ratio. We are adding double the figure which are in the middle two stages. So double of AB square is 2AB square. Double of A square B is 2A square B. So that when we add together, it becomes A cube plus 3A square B plus 3AB square plus B cube, which is nothing but A plus B whole cube. So when we know what is the value of A, what is the value of B, maintain right first A cube, that is a tens place cube, tens place square into unit place, tens place into square of unit place, and cube of unit place. Add double the middle numbers to get the cube. 53 cube. So A is 5, B is 3. So first one is A cube, 5 cube. A square into B, 5 square into 3, 75. A into B square, 5 into 3 square, 9 5 are 45. And 3 cube is 27. Add double the figures. Seven carry over 2. So 53 cube is 148877. If it is 503 cube, still you can have A and B as 5 is to 3 only. Only thing is B is 2 digits. So you have to maintain two digits here. And now 125 is to 75, 45, 27, double of this, double of this. Only thing is, instead of single digits, we have to keep 2 digits. So 27. So the 503 cube is 127, 26, 35, 27. So let us take one example of 29 cube. This can be solved with the ratio proportion method in 2 ways. Because 9 is a bigger digit, we can convert it into with theorem. 29 means 30 minus 1 or 3 bar 1. So you can compare the results later on. 2 cube, A square B, A into B square, and 9 cube. Add double the figures. because B is a single digit, we will have to keep single digit, rest being carried forward. So it is 24,389. Just you can observe how much we will have to carry out. Now here 3 is A and bar 1 is B. So 3 cube. (27). A square into B. 3 square into bar 1. A into B square. Bar 1 square is 1 into 3. And bar 1 cube. Bar 1. Double of 3. Double of bar 9. Now just convert. This is a Vinculum number. Only thing you have to convert. 5 bar 7 means 43. 9 bar 1 means 89. So we accept a small carryover here. The answer is 24,389. 24,389. 19,996 cube. So because all these are bigger digits, it is better to convert it into Vinculum. So that you can keep A as 2 and 000 bar 4 as B, so that your right hand and middle two parts will be of 4 digits each. Now the ratio is 1:2 bar 2. So 2 cube or A square into B. We want to get 4 digits. A into B square B cube. Or the ratio is 1:2 bar 2, 8:16, or 8:2 bar 16 is 1:2 bar 2, 1:2 bar 2, 1:2 bar 2. So we have maintained the ratio also. Add double the figure. So this is the answer. So in this way, by using Anurupena Vedic formula, we can find the cubes of such big numbers also.